Hello class, today we are learning about the difference between a relation and a function. So today's essential question, how do I identify a function? Learning intention, I'm learning to recognize the difference between a function and a relation. So pause the video now and solve this warm-up. If you don't remember how to solve this warm-up, think about it. There are lines. Two lines can intersect either at a single point, or they can be the same line, or they can be parallel. What do you notice about these two equations? I'll give you a hint. They are both equal to y. If they're both equal to y, what do we know about those two equations? Pause the video and solve. If they're both equal to y, then they are equal to each other. I hope you got that. Negative 2x plus 2 is equal to 4x minus 16. They are equal to each other. Now we solve for x. Which one's smaller, negative 2x or positive 4x? Well, negative 2x is, so that is the one we want to move to the other side. I will add 2x to both sides. I've eliminated it on one side. I'm left with 2 is equal to 2x plus 4x is 6x minus 16. Now I need to move the 16 to the other side. The opposite of subtraction is to add. What I do to one side, I have to do to the other. I eliminated on this side. 2 plus 16 is 18, is equal to 6x. Last step, divide by 6. 3 is equal to x. Now when we're dealing with a line, we know that it has to be a point or a set of points when we're looking for our solution. So our x value is 3, but what is the y value? How do I find it? I've got two different equations I can use, and I will use substitution with the fact that x is equal to 3. Y is equal to negative 2x plus 2. That's the original equation. Substitute 3 in for x. Y is equal to negative 2 times 3 plus 2. Solve. Y is equal to negative 6 plus 2. Y is equal to negative 4. So their point of intersections, these two intersect at a single point. That is a point 3, negative 4. So as we're learning the difference between functions and relations, we have to define what each of them are. So a relation is the pairing of two sets of values. Okay, there's no order, there's no rhyme, there's no reason why we're putting them together. We're just taking two different sets of values and putting them together. We take one set of values as the input and one set of values is the output. So each input gets paired with an output. So if we're looking at this, a relation is just putting any two numbers together. One has to come from the input, one has to come from the output. Now, a function, it has a special quality. A function is a relation in which each input is paired with exactly one output. Okay, and remember, the set of inputs is what we call our domain. The set of outputs is what we call the range. So, for each input, each member of the domain, there is only one output or member of the range. This brings us to the vertical line test. The vertical line test is a test we use for graphs. And it tells us that if the graph is a function, if and only if all vertical lines intersect the graph at one point only. Okay, now we need to know what IFF means. IFF means if and only if. Saves a lot of writing. So if you draw that vertical, that straight up and down line on your graph, it will only hit your graph or intersect your graph at one point. So we're going to start analyzing now. We're going to look at the functions and see if they are a relation or a function. So what we need to do, we need to look at our inputs, our x values. Each input can only be paired with one output. -2 is paired with -2. 0 is paired with 5. 1 is paired with 6. 1 is paired with 7. 2 is paired with 1. 3 is paired with 2. Do our x values repeat? Yes. If we look at these 2 points, both of these 2 points have an x value of 1. It is not a function. Because. B/C means because. One is mapped to 6 and 1 is mapped to 7. So this little arrow here means is mapped to. So we look at those x values. Remember our points are x and then y. So we're looking at that first value. If that first value repeats, it is not a function. Let's look at the second set. Remember, our focus is only on that first number. What is x? So as I'm looking at x only, 0, 2, 3, 4, 5, 6, negative 5. Do any of those repeat? No. If they don't repeat, then it is a function. And it's a function because the x values do not repeat. Okay, now it's time for you to try the next one on your own. Pause the video and see if you can determine whether or not it is a function. Pause the video now, please. Is this last set of points a function or not a function? Okay, let's take a minute and look at our x values. 0, 1, 2, 0, 5, 3, negative 5. Did I repeat any of the numbers? Yes, I did. I repeated 0. If I repeat my x values, is it a function? No, this is not a function. Zero is mapped to 5, and 0 is mapped to 4. So I hope when you did it on your own that you found out it was not a function and you knew why. Okay, let's look at this next mapping. We're going to sketch it and see if it is a function. So the first time we look at 1, it's paired up with negative 2. That would be the point 1, comma, negative 2. We look at 1 again, and it is paired up with positive 2. 1, positive 2. 3 is paired up with 0 only. Negative 5 goes to positive 4, and negative 5 goes to negative 4. So look at those, and now that you know how to read it, is it a function? No. So as we're looking at this, remember, if that x value repeats, it is not a function. As we're graphing this, 1, negative 2, so go over 1 and down 2. 1, positive 2, go over 1 and up 2. 3, 0. Negative 5, 4, go to the left and then go up. Negative 5, negative 4, go to the left and go down. As you can see, it does not pass that vertical line test. I can make 2 different vertical lines that intersect this graph in more than one point. So it is not. It does not pass the vertical line test because -5 is mapped to 4 and -5 is mapped to -4. This is the line we're looking at, and that's where we know it's not a function. Okay, pause the video on the next two and see if they are or if they are not. I hope you try it on your own. How about the first one? Is it a function? If you answered no, you are correct. One is mapped to 3 and 1 is mapped to 4. Not a function. What about the next one? Each of these numbers have only one arrow coming out. Yes, it is a function. Does this pass the vertical line test? How many of you know that that is the parent graph for the absolute value equation? And it's actually the absolute value function. The parent graph would start here. This is the absolute value function after it's been translated. So this is a function. Passes that vertical line test. How about a circle? Will a circle pass the vertical line test? No, in fact, it doesn't pass anywhere except on the very, very most extreme edges. So this is not a function. It intersects at -2, 2, and -2, -2. So all you have to do is look at that x values. If they do not repeat, it's a function. When you draw that vertical line, if it hits at only one spot, it is a function. So functions versus relations. A function is a relation, but a relation is not always a function.